Alright, welcome back. It's Jared from Jayco Electrical Group. As you can see, we have a Jayco All-Terrain behind us. This is a pop-top model. Customer is here because they can't run off-grid, so they got no inverter. Got one 100 amp hour battery or 120, which is very poor BMS-wise and won't run an inverter once they put one in. Two solar panels on the roof running through the projector system, which he feels aren't charging enough, if at all, and then there's no charge at all from the car whilst they drive. Like I just said, the van itself is basically as it comes from factory. You've got the projector system underneath the bench seat with the battery there. What we're gonna do is utilize this space over here and bring the weight of the electrical system more central to the van, rather than trying to put everything on this side in the bench seat. Your weight's gonna all be on that side, so we're gonna try, or we're not gonna try, we are going to. Battery and the box there is gonna get deleted. We're gonna run a new circuit to then reconnect up the stuff that's connected to that battery and fuse it. The solar here, which is what the boys have already worked out, that this is the roof circuit, so we're gonna extend that for the roof array. And then he also has an Anderson plug-in, which will continue to run into the projector system, which is the circuit down here going into the solar. So that way he is going to keep his solar, the roof array, completely separate from his ground array, and then keep them 100% efficient across both. Because if he's going to plug in his blanket to the roof array circuit, that blanket might not run at the same voltage as what the ones on the roof are running at, and he's just going to kill his efficiency. So we keep it set up that way, and then add the Victron Solar Controller. At the moment, he's got two like 170, 180 watt panels on the roof. I'm about to get up there and measure them and talk to him and see what he wants to do, whether he wants to get rid of them and do like 3 or 4 all new ones. We're going to try and fit 4, maybe 5 up there. We'll see how we go. Now, so what we're going to be doing is two 340 amp hour batteries underneath the bed here, with the multi-plus probably sitting up the side there, the 50 amp Victron Orion XS DC charger, and then the solar controller all under here. I'm going to try and keep the battery sort of in this area to try and keep the weight central again, and then the multi-plus sit it up against the wall on the side. Now, as you can see, we've already got tongues and stuff running through, so we've worked out, all right, we know exactly where we need to tap in for the 240 AC power. That's what that's for. We're going to have a hole in the floor near that hole that's already there for cable to then come up here. So we're going to have two 12 volt circuits, one for the battery, one for the solar, and then we're also going to have two 240 AC cables, which are both going to run through to the AC short power plug-in, which I'll show you in a sec. DC charger wise, so at the moment the van has an Anderson plug on the front, but that is just going to his fridge, and he's actually got nothing running through the 5-pin side of the 12-pin. So what I'm going to do is I'm going to move the Anderson plug active and neutral to the 12-pin side, and then I'll do the same on his car. So then now the fridge will run through the 12-pin plug, and then I'll run a new Anderson plug so that he still only has one grey Anderson plug on the van, which will run his 50 amp Victron DC charger, and then that will also just keep it as is. So he's got one Anderson plug already on the car, he's only going to have one on the van. We're not adding another one to the van. We're going to move that and run it through the 12-pin plug, and then on the car we're just going to loop from the Anderson plug over to the 12-pin plug to then run his fridge as well. Alright, so we're at the back corner of the van here, which he has his 240 AC plug-in, and now that comes to this cable here, and it goes off into this splitter, which is what Jayco uses in all their vans. It works, but it's not very nice. So what we're going to do, and that's the other end of the tongue, run our two 240 cables to here. I'll show you with our example here actually. So multi-plus 12-3000, so 3 kVA unit, 12 volt model. It's also a 120 amp battery charger. So this is just our workshop display unit. So that's our shore power here on the unit, which is the exact same as the shore power that's here, okay? That's just a different style of plug because we use them on, they're just a lot better than having the plastic stuff. Basically, cable comes from here, 240 comes through the circuit breaker, and then up into the multi-plus. When you're plugging into the mains here, you've got the plug-in on one side, and then you've got the RCD on the other side. So then we'll tap into that, and we're gonna run that cable all the way down underneath and up into the bed area. Don't mind the lunch truck. And then, so that's our 240, I think it's that one, 240 input into this. So then that will use the transfer switch and change over into charger mode, but then it'll also run all the power points off of the shore power. So then that'll charge the battery that's in there. So in this van, it'll be the batteries in the van, and then output side, so when you're not plugged into mains power, the inverter will have a cable running from the inverter. Again, same run all the way back and up into this section, and it'll tap into like this side and run the whole van off the battery system in inverter mode. He isn't going to have this screen, but there's we're going to do a different battery monitor and different multi-control screen, which will basically mirror all this stuff. The inverter is going to run the whole van. We're not going to have it set up so that the inverter is just running a designated power point. The way we do all our inverters, and hence why we use the multi-plus unit so much, is the inverter runs the whole van. It doesn't just run one power point. I literally had a Jayco in it yesterday, and that's how they had wired it up. And I was like, they've done all the hard work by wiring up the inverter, but you've just got the inverter running one power point. Like, yeah, okay, it's a little bit of work to run on the AC stuff, but I mean, the reason why we see it so often that people don't do it is because you have to be a licensed electrician to do that. I'm a Sparky by trade, so we are licensed to run all the 240 AC wiring and then sign off on it as well. But yeah, I'm gonna jump on the roof now, measure up the solar, talk to the customer, see what he wants to do solar wise. The voltage that these panels are putting out is 18.5, which is not too bad. I'd like another volt or two would be ideal, but it might be more efficient for this customer to just swap out all of them, because we're going to be taking these ones that are on the roof now off anyway to adjust how they're going to sit. Okay, so here's the roof of the van. What I'm going to do now is measure up the distance between here and there, and the distance between that dust reduction system in the front, and see if we can actually take up one panel, two panel, pull them up, twist them, and put them back down, and then so that this one is going to sort of sit there, and then we fit another one in here and another one. So then that's 4 straight away, and then we could potentially do 5 over there. But like I said, the voltage of these is, I think, 18.5, 19 volts. I would have loved another volt or two on these panels. And the panels just get like that with age. I feel like there's water sitting on that one, so I'll clean the water off and I'll do another voltage measurement, and then just try and marry them up with our panels up here. So like the 180s here, you see a 20.4 volt. And then these will be the same, 20.4 volt. They're the 200 watters. So it's more just a game of Tetris and what's going to fit size-wise, because our voltages are going to stay the same, so they can all work together and marry up. Boys are starting running all the cables. As you can see out down there, I'll show you them. So here we've got the two 12-volt circuits. So we got the thicker one, which is going to connect up to what was on the battery, and then this 6mm twin is going to be our solar extension. And then we've got the two 240 circuits. So we're going to have an input and an output. Now, one thing to note is, I don't know how well I can get that to focus, we use 2.5mm flex twin and earth. Or a lot of vans that we see will always have like a standard house-wide TPS, which is only 16 strands, and this would be like 32 strands. This stuff handles the corrugations dramatically better than that standard stuff. Like, I've pulled power points off vans in the past where there's literally only like 4 or 5 strands left hanging on that are actually powering that power point. If you are getting stuff done, buy an electrician because they only ever use TPS, or you're getting 240 or something done on your van, ask them what is the type of 240 cable you're running. It should be 2.5mm 2-core and earth, or 3-core flex core. And then obviously that's going to be in all its cable protection as well underneath the vehicle, in all its Corrie, and then black Corrie for the 12-volt stuff. So as we spoke about, this van, he's getting 2 340 amp hour lithiums. We're running them in a 12-volt configuration. Now, what I'm going to show you here, this is one of, if not the most important part of the process when linking multiple lithium batteries together. What I did yesterday was I charged these two, and now I'll go into the app for the BMS of both of them. So one was on charge overnight, and then the other one I charged up yesterday. So you'll see here, one's 13.75, 99%. Second one's that one there, I know is 6A, because it's got a serial number there. And I know, okay, this one's the one that just got taken off charge because it's at a high voltage. So what I'm going to do now is turn them both on. I've wired them together, so active to active, neutral to neutral. This is the active balancing BMS doing its things. There's an active balancer in each battery. It's a 2 amp active balancer. But what they're going to do is work across both batteries. So I'll come back here in like maybe an hour. All 4 cells in each battery should all be the same voltage across the board, which we can see exactly what cell is what voltage here. So it's 7 AM, so I'll come back at 8 AM and I'll open up the app again on my phone and see what each cell is doing. By then I would expect those batteries to basically be balanced. At that stage, then they are okay to then wire in. And we know that when we put them in there that they're basically full. Could probably do with another little tiny charge once they're balanced, but we know that they're basically at 100%. So that'll allow us to then set the battery monitor for the customer to 100% straight away, and we go, all right, cool, we know that this battery monitor is synced up with the battery because we're going to be running the Victron battery monitor. So rather than him have to go into the app and read both batteries individually, he can just look at the battery monitor and read it as one whole system. That way as well, let's say you're drawing 20 amps off the system. If you go into each battery individually, you'll only read that you're drawing 10 amps because you're only drawing half the amount because you're doing it across 2 batteries. So that's why doing multiple batteries must have a battery monitor. And a lot of the time, the Bluetooth BMS, so like on that one, they're 340 amp hour batteries. When I charged it up yesterday, it read, I think it was like 352 amp hours. Using the Victron battery monitor, you set it to 340 and you set the discharge floor. It's a lot easier for the customer to go, okay, I actually know how much of our user energy we got, and the Victron one, a lot of the time will be very, very accurate. That's why we install them in everything. It's now 8 AM. I've had these batteries doing their balancing. 100%, 13.91. Our cells are all within 3.47, 3.48. So that one was a 601, so let's do the 6A one. All our cells again, 3.47, 3.48, 13.9, 13.91 voltage wise. Exactly the same across both. So that was only an hour, and both batteries have balanced with each other. So now we will get the CNC box cut, put it in, and then work out where all the other bits and pieces are going to sit. The roof's now done, as we can see. So what we've done here is 180 and 180 are the original ones, and then there's these 2 new 180 watt panels. The voltage on these was a little bit lower than the 2 new ones. So these are a 20 volt, these were a 19, but I've done the math for the customer and basically going to be running at roughly 94% efficiency over 720 watts. Which the customer was fine with doing. Obviously, again, we're always keeping in mind our customer's budget, and we'll liaise with them throughout the build what they want to do with the solar. We hold 99% of the panels that we use in stock at any one time up the top there. So we can sort of just mix and match and do the most efficient setup for the customer. Okay, so we've now done the Anderson plug. So this Anderson plug here is a new one, a 16mm twin. That's going to do the DC charger, and I've moved the fridge into the 5-pin side of the 12-pin. So he'll still run the fridge, and then we are just going to rewire his car a little bit to put power into the 12-pin side if it's not there. And we're just going to put an isolator, we just use like a Red Arc SPR 12 isolator on the car to then have that Anderson plug on his car that is isolated, not just on with the starter battery, because that's how it's been wired up on his 200 series at the minute. We've got the multi-screen and the battery monitor mounted up. So we've got them cut in, run nice and neatly on the back of the cabinetry. We've got the battery box ready to go. We've sealed that all up. The lid for the battery box is just over there, which will put our foam lid on. Got multi-plus DC solar controller all happening. We're almost there. Today's last day. Just got to do basically that under bed area, program everything, and I'll start making up the compliance sheet today to just say, yep, certificate and all the like Victron components, their serial numbers, warranties, batteries, and then I'll also do a customer specific video for the van, like troubleshooting wise, so that they can know where their fuses are, what fuses do what, and what to look for if they don't have AC power or something. Put another circuit breaker in for the multi-plus. Boys are just having some lunch, so what I'm doing now is going through and programming everything. I've just done the solar controller, and now I'm doing the Orion XS, so the 50 amp DC charger, doing things like programming them to Lithium, changing the pin code so that the pin codes are all relative to us at JT and that the same across the whole system. That way I know no one's touched it since we programmed it. If they do ever run into issues. I've got the multi-plus plugged into the laptop. Go in and I'll set this to Lithium, set the charge profile, set the AC input amount, but then he's also going to have the screen, so I'll make sure there's a setting in here where you can actually make sure that it is overridden by the screen. Otherwise the dial on the screen, they won't be able to adjust. Another piece of the puzzle is doing all the software updates across all the charging devices. They just come with like a sort of stock firmware. So like for the multi-plus, for example, we're updating from 508 to 522, so making sure that a lot of the stock lithium settings will be 14.2. For like an absorption charger, we change that to 14.4, and then our float charge from 13.5 to 13.6, because we know that's what these batteries and the BMS inside these batteries is going to handle to charge them to the full 100%. That's one big thing. Some lithium cells might be different voltages, their BMSs might be set up differently. If you just go to the stock standard lithium setting, it might not be charging your lithiums to the full 100%. You just got to make sure you know what you're doing when you are programming them. And then we just got to hook up the AC, start doing a bit of a pressure test on the system, making sure it's doing what it's meant to be doing. We've got the batteries now in the box, so they're wired up, and what we've done here, active off this battery, neutral off the other battery. So that way, if you have the neutral coming off this battery, you have imbalances with your battery percentage, so we keep them like that. You're essentially, it's all one battery cell. Yes, the active balancer in each battery will work to make sure that all 4 cells in each battery are balanced. But yeah, I'm just going to program these up and then we'll get on to pretty much the final bit. This Jayco All-Terrain is now finished. So I've got the battery box with all the AS3001 stickers, 300 amp manual reset circuit breaker for the inverter. You got your shunt there, so that's our battery monitor, which I'll show you the screen for that in a second. That's monitoring the whole system. Got an inverter with our RCBO. I just need to put a pole filler in there. So that does our output. And then there's one at the short power plug-in of this fan for the input side of things. Got 50 amp DC charger, 50 amp solar charger, and we've upgraded the solar on his roof to 720 watts total. So this is your option for inverter and battery monitoring if you don't go for the turbo unit, the servo. So you've got input current limit dial here, where you can turn that up and down. That's the 240 AC side current wise. And then you've got a battery monitor here, which is also Bluetooth. So this just mirrors exactly what's on this screen to what you see on the Bluetooth app, which I'll show you just here. So this is the battery monitor. This is just on my laptop, but same thing on your phone. Battery percentage, voltage, current, power in watts, consumed amp hours. So he's got 2 340 amp hour 12 volt batteries. So he's got, what, 680 amp hours. So he's got a lot of juice to use. As you'll see, I'm going to put a little pressure test of this system running at 4,000 watts for about 1.5 minutes, 2 minutes, running his air heater and this kettle that I've got behind me here. Now, things get hot at that, but these batteries are good enough that they can handle that. These inverters are good enough that they can handle that. There's a lot of things on the market, especially batteries, that won't have high enough discharge BMS power that they can handle that. And we've always been about high discharge BMSs in lithium batteries, because there's a lot of crap on the market, but then there's also a lot of batteries that are expensive, but it's just a facade to think, oh yeah, it's an expensive battery, it's good, because they actually have a very poor BMS. So the battery system was over here. So you had the battery box here, so he's gained all that space back, and we've just moved to stud terminals, put rubber boots on them, to continue to power his projector system, which he can still control his hot water system, his water pump, and isolate his 12 volt circuits. So this is basically like screen, I guess, for all his 12 volt outputs. The battery monitor on here, we're just going to disregard anymore because it doesn't read the whole system, and that's why we've got that one there. Still keep the projector, it's fine to just do the 12 volt, but all this charging stuff will now come through the Victron system down here. In the system here, we've obviously got the 3 kVA multi-plus, which we use in basically all the systems. 120 amp battery charger, 3 kVA multi, but you'll see in the next little bit that it can go above the 3 kVA. It's a very, very sturdy bit of kit, hence why we install so many of them. That's your 120 amp battery charger. And let's say, all right, we're running off the batteries, the inverter running, say, the kettle. I'll turn on the kettle, and that kettle is running at 73 amps. One of the boys is just plugged in the shore power and we're drawing 172 amps. Now this unit is going to do its manual flick over. That's it there, just made the noise. And you can see here, we're actually still being able to charge at 40 amps, even still boiling the kettle, okay? So that is how good this unit is with swapping it over. And now this kettle is almost done. So we're still at 41 amps now, we're charging 44 amps. And then as soon as this ticks off, this will go straight back up to the 110, 120 odd amps of AC charge. That right there is a perfect example of why we use these inverters and why we trust them, and why we put them in pretty much every single job that we do. They're such a good bit of kit, and for the price that you pay for them these days, they are very good value for money, I feel. This was a 680 amp hour lithium battery upgrade system with an inverter on the Jayco All-Terrain Pop top. If you liked it, or you got any questions, put them in the comments and I'll do my best to answer them. And if not, we'll see you next video. I'm gonna do a bit of a pressure test here, all right? So I'll turn these on individually. So we got our kettle here on, pulling 2300 odd watts, 160 amps, okay? And then we've got the air heating unit, just pulling a further 1500, okay? So what we're gonna do is turn them on together. We are cranking 4,000 watts, 300 amps off this battery system. And yes, the inverter is telling us that it's in overload, but it's still doing it. We're not plugged into shore power, no mains power accessible.